Hi, I'm Lynn Langett for Teaching Kids Programming, and we're glad you're here. In this short video, I'm going to talk to you about what Teaching Kids Programming is, why we created it, and how you can use it to introduce kids ages 10 and up around the world to computational thinking with TKPJava. So let's get started. First, I'm going to tour you through our website. Our website you can think of as kind of an index for all the various pieces of content we have to work with kids. So that you can understand how our courseware works, I'm going to actually just start by showing you an example. So here I am inside of Eclipse. This is a customized version of Eclipse, which you get by downloading our courseware and the Eclipse configuration from our site. Directions in a minute. The core concepts behind Teaching Kids Programming is we've created a library based on logo and working with the tortoise and some other concepts, and I have a list of references at the end of what our influences were. The idea is that we've created bridge courseware. This is specifically designed for middle school students so that they've possibly worked with visual programming such as Scratch or Kodu or some other sort of visual programming environment, maybe Lego Mindstorms, and they now want to start working with a core language. What we found in our work teaching kids around the world, and as professional programmers, because nearly all of us are, that going directly from a visual environment to a full programming language, particularly an OOP language like Java, is really formidable. So we created a fun library that's bridge courseware. So here's some of the core concepts. Each of the lessons has English comments, and you notice that at the end of each line there are line numbers, and there's a specific reason for that. One of the things that makes learning fun is feedback. And so we've written our recipes in a way that you can translate one line of English into one line of code and then run it and see the results, and that's your validation. So I'll just give you a couple lines so you can see how it goes. So I'm going to do a control space to make a new line. Then I would have the kid read the line, so show the tortoise, and I would say, what is the noun? Tortoise, and they would type TOR, and in addition to our library, we also try to incorporate best programming practices, which includes use of tools. So we would teach them then control space, which would give a keyboard shortcut for the entire word. Notice also we've carefully written documentation, including graphics and fun jokes and stuff like that, just so the kids can get into the habit of reading the documentation. Then we would tell them to press enter. And then we would say in English, we separate our words with spaces. In Java, we separate them with the period. So to separate the noun from the verb per se. And we would ask them, what's the verb? And they would say show. And then we would say, use the arrow key to go up and down, or look actually for that word, and maybe you can start typing it. And so they might start typing SH, and then they would actually see it. Now, we have carefully done a one-to-one translation between the English comments and our library. We've encapsulated core Java to make the on-ramping easier. And in each lesson, we teach 1 to 3 programming concepts, and we start easy, if you will, with a one-to-one, and then we slowly move closer to the real-world Java, where you'd have regular English, and then it wouldn't exactly match the API. And this is done by design. So then we'd say press enter, and we'd say in English you end your sentence with a period, and in Java you end it with a semicolon. Notice the use here of incorporation to something the kid is going to be familiar with, which is grammar. We purposely are not saying class or method at this point. This will come later. The way that we teach is it's a layered learning, so it's experiential. The kid first experiences it, and then once they're interested in the subsequent lessons, we will layer on the programmatic terms. So then we would say, did it work? And they'd say, well, I don't know how. And we'd say, play it or run it. So we'd click play, and we'd say, okay. And there we would have our tortoise. So yay. Then the next thing we would do is, another habit we're trying to teach is that properly written code is expressive and really shouldn't require a lot of comments. So we would have them delete the comment, and we would use a keyboard shortcut to do that, which is, in my case, of a Mac Command D. So then we would have them go to the next line, which not this one because we couldn't see the feedback. It's not moving. We would go down here, say move the tortoise 50 pixels, control space, and we would say TOR, control space, and enter. And we wouldn't be telling the kid this, we would be asking the kid. Another important aspect of our courseware is we use the Socratic method because we feel that the kid must learn to take the English comment and then explore using the tools in the editor to be able to translate, which we feel is like real world programming. So we would say, okay, then what is the verb? And then we give them the hint of you can start typing, and they'd start typing. And then over here on the right side, you can see that we've done examples for everything. However, our examples purposely do not match. So if the kid is really stuck, they could copy and paste, but it wouldn't get them to the right answer. Now in this case, it's probably simpler. They could probably figure out 50. We would just say, how far is it? And then of course, we would ask them to run it after each line. So they would run it. And by this time they would be really happy. And then we would ask them, what do you do next? And hopefully they would say, get rid of the comment. What is the keyboard shortcut? So Command D in the case of a Mac. And then which line do you do next? And hopefully they would say this one. And then we would say, read it out. And they would say, turn the tortoise to the right 90 degrees. We'd go Shift Enter. What is the noun? Hopefully they would say tortoise. And we'd say, what would you type? TOR. How would you complete it? Control space. And then press Enter. What is the verb? Hopefully they'd say turn. Type T. Notice T, degrees to the right. And then we would say, hopefully they'd say 90. And then they would run it. So you're kind of seeing the progression here, hopefully. And then there we go. And then we would say, what do you do here? And they would delete it. So you can see that we have a number of sections, which we call courses. So we have 9 sections. We have some demo recipes that really just encapsulate some of our processes a little more quickly. If you need to do a 5-minute demo, these aren't really for the students. And we have 2 sections in our code. The section that we give to you for the kids just has the questions. The section that you can work with as a teacher has the answers. So you can see if I expand this here and I go into recipes and we go into completed and we go into section 1 for loops, that this mirrors, and in fact it has some additions here which I'll get into a little bit later in this talk. But if we go into simple square, there is the answer per se. Now we don't this is for teacher preparation. This is not for the kids. The idea is that the kids must complete the each recipe, and they are written in a very specific order. Part of the courseware design is mastery-based learning. So it's very much like something like math, where one builds on another, and the lessons or recipes are written in a specific order, and the sections are written in a specific order so that skills can be expanded upon. So that gives you kind of an idea of what the courseware looks like. Now for you as a teacher, we're going to return to the website and look at the resources that we've created in addition to the code to help support you in teaching this. So first, navigating the website, it's really pretty simple. We have courseware, FAQ, team, and donate because we're a nonprofit. Over here we have my Twitter. This leads to the main repository, and this allows you to give us feedback. So if you click Go to Courseware, you can see, as I mentioned, this is kind of an index. So you have index for each of the sections, and this is a pretty big section with a lot more detail on our instructional design principles. So intentional coding, mastery-based learning, incorporation of Agile and XP practices. And I know that some teachers are really interested in this and some teachers are less, so we pulled it out as a separate section. This is the start of the courseware itself, and then when you go into each section, it'll explain to you the concepts that are taught, and then we have one sample video from the various lessons in the section. So there'll be for between 6 and 8 lessons in each course or section, and we'll only have one video here because frankly it takes a lot of time to make videos, and our teachers have told us they prefer written information. So if you click download lesson plan, that takes you over to our written lesson plans. And this is about a 100-page book. Let me go back up here. This is in something called Penflip, and it's available online, but you can download a version by just clicking download over here. Or actually you can fork it and make a copy, make your own version just for yourself. And the way that you would do that is clicking over here once you got an account. And what this does is, this is the first lesson, for example. It lists how you would prepare as a teacher. So install the courseware, read the lesson plan, code the recipes, then look at some other resources. It shows the recipes, and we have links to all the answers. So for your own preparation, again, this is not for the students, this is for the teachers. And then we have written information. And I'll be honest, this is a light amount of written information. So I believe that in order to properly teach this, you're going to need to look at the answers, work through and code, and read this in terms of your preparation. In addition to the courseware, we have an FAQ, which I'm probably pretty much covering in this video. And then we have our team. We're a volunteer team, mostly professional developers. So just going through the resources, our code is found on our GitHub repository. So we have 2 different TKPJava repositories. The sections are linked through our website. The one that you'll be working with for your kids is Teaching Kids Programming Java. That's the one with the exercises and not the answers. We have a pretty extensive explanation of how to install. It's really not that difficult, but we do ask that you please read this because it does require that you perform these steps. We support installation on Windows and Mac. It's possible to install on Linux, I believe. I've done it once, but again, we're limited in resources, so this is what we are giving instructions for. If you are a developer or you have a development background, this is where we write the original code and we compile it and we build for our teaching repository. So you're welcome to, take a look in there and submit pull requests if you have suggestions. In addition, we are experimenting with other languages. Most of these are forked from other people's repositories. So we have one from Go, we have one JavaScript, we have Python and R. We haven't really released anything into production yet. We're just experimenting. But if you are interested in those languages, we would welcome your contributions. In addition to GitHub, we have our YouTube channel. And again, all of these videos are linked at the various points in the courseware. But if you're a person who just prefers to watch videos, we have a playlist around TKP Java for K-12 teachers. So we have 14 videos there. And we also have a Java tips. So if you prefer, you can just go directly to our YouTube channel. If you're a teacher who likes to prepare by reading, I know I've had several teachers take this route. You can work with the entire Penflip, which I said is about 100 pages, and you can just work through. In particular, I know I have some teachers that are very interested in our instructional design information. So I'm working on this to flesh it out a little bit more. I think probably written it's about 15 pages or so, but it talks about things, why do we use techniques like pair programming or group or mob programming? What are the different parts of each course? What is more information about the instructional design? I've started because I've had requests to map to the AP Java exam. Even though we are a bridge courseware, we do teach, the core concepts like objects, properties, and methods, events, so on and so forth. And although we don't create courseware for exam success, in looking at this, I found that we do have a lot of the concepts. So if that's a need for you as a teacher, we've already worked in mapping this as well. In addition to this, as I showed, we do advocate for using keyboard shortcuts. So we've got them here, and you can print this out as a poster. If you want the original Word doc, just ping me, and then you can, edit it however it works best for you. We have an alternative editor that we work with that I'll show you in a minute here called CodeNB. So I have keyboard shortcuts for that as well. Another thing that we have to work with is TKP Java language notes, and this is just an anchoring PowerPoint for some of the core language concepts. And again, when you read through our instructional design, the way we advocate teaching this is just when you're teaching the concept, you can just show this slide as an anchoring slide, and this is in order as per our courseware, or you can show it when you're doing the recap or review section, or not at all. I just find personally that when I teach kids, it helps them to focus on some of the trickier language concepts. I mean, you can see things we have like hash maps and, for eaching, array lists, things that maybe are a little bit more abstract, especially if the kids are younger. So in addition to these resources, we have a utility called Virtual Proctor. And what this is, technically, it is a website hosted on Google Cloud, actually. And what it does is it allows you to showcase the students' work. And it's really fun because when the kids are coding in the section called Variations, where they're varying the code and kind of free-forming, then you can almost have a competition. And notice down here, I've got some class names and I've got some student names, and you can filter by that. So you can see all. And so it's really fun to showcase what the kids are doing. Also, it can be useful for you as a teacher. If you have a really big class, you can see where the class is at. So another thing I want to show you in this video is some future work that we're doing. We're working with a vendor called CodeEnvy to create an alternative editor. As you may remember from earlier in this video, we use as our core editor Eclipse, a customization of Eclipse. We have gotten a lot of requests from teachers who are working with Chromebooks for an online editor, and also just for teachers in general, because this is a zero install. You just go to an endpoint. So we are early in this work, and we have I'll show you where it is here. We have a page that talks about our beta. So if you're interested in working with this, you can go to this page, and it talks about it. Do be aware that it's a beta. So this is not in any way, shape, or form intended for prime time, and it changes very frequently. But some of you guys are very technically astute, and you're comfortable with this, so you're welcome to join in the beta, and I'll just show you how it works. So I went to the endpoint, and then I'm going to do control space and TOR, control space. Again, I'm kind of skipping because I showed you this earlier. Enter period, and then I'm going to type show and control space, and then I'm going to put a semicolon, and then I'm going to go ahead and run. And again, technically what's going on here is you have this hosted on vendor cloud, and this is spinning up an set of instances to build and run this code separately. So just like Eclipse is actually a professional editor that professional developers use, CodeEnvy and the CodeEnvy tools are professional development tools. We're just customizing them for use with kids. And once this is completed, you can then go here and you can spin up your instance, and you can see that we have it, and we hook into the onClose event. So we close here and we close here, and then kind of fun, you can see here, and this is from CodeEnvy. So it all works with the virtual proctor as well. So a couple things that are interesting. Let's see, I'll go down here to control space and kind of do the same thing I did in the other one. So tortoise dot, and then I'll type move and control space move, and then I'll say 50, and then end. Put my end on here. I think this might do it actually. No, not yet. So they're working on the add-ins to do the completion. So a couple things here. Remember in the Eclipse version we had the Java docs, and we have that here as well. So here's our quick documentation, and then we have our example. So again, this is an important technique in our teaching, that we have the kids look stuff up when they're stuck. And also in here, what we can do is we can actually go back to source, which is a little bit interesting. So we can open the declaration. Again, this is a bit more advanced, but I know I have had students that are interested in this. And you're actually now back in the source code, which not meant to modify, obviously, for the students early on. But, it's great that these kids are really, really interested in it. Also, an interesting aspect of CodeEnvy is integration with Git. So if the kids want to have their own GitHub repository as they're working along, they can do that. So if this is something you're interested in, like I said, I encourage you to go to, a documentation that we've written, the example, go over here, take a look at it, and then we talk all about how to work with CodeEnvy. So the reason for making this video, and the reason for making Teaching Kids Programming, is because of what we professional programmers see as a huge need in our education system, which is to provide resources for our middle school teachers to introduce computational thinking to kids ages 10 and up. Most of our customers that we know of are middle school teachers. However, we do have some high school teachers who use our courseware as a supplement to AP Java, and they're having some really good success with helping kids who are coming into AP Java, maybe don't have a huge background, who go through some of the lessons or sections in Teaching Kids Programming, and they then learn some of the concepts that they maybe didn't get from going over Scratch and some of the other visual programming languages, and then they have success in AP Java. So we're very excited to work with students and teachers all around the world, and we love to get your feedback. So if you are working with Teaching Kids Programming and you've gone through the documentation, you have a question, you have a suggestion for feedback, please let us know. And we are excited that you're working with us to educate the next generation of programmers. Thanks again. This is Lynn Langett for Teaching Kids Programming.